Hi, fellow Earthling students. Welcome to the video on writing large numbers in scientific notation. Okay, let's be real. I'm not going to talk like that the whole video. But as you can see, I'm flying through space right now because a lot of famous astronomers and scientists use scientific notation to write really, really large numbers. So for a minute, I want you to think about space. And I want you to think about how far it is from here to the moon. Just take a little rough estimate amount and think about how far distance-wise it is from Earth to the moon. Now to answer your question, it's about 238,855 miles away. Okay. But what if they need to measure something in very, very tiny measurements and they need to use inches? The moon is 15,960,000,000 inches away. That's a very, very big number. And people like Albert Einstein are like, are you kidding me? Like, there's got to be an easier way to write such big numbers. It takes a lot of time and effort, to be honest, to write very big numbers, and they can be difficult to read. So they developed something called scientific notation, which is an easier way to write really, really large and small numbers. Excuse me. This video is just going to focus on large numbers. So let's take that number. In order to write this into scientific notation, we use the base powers of 10. And we need to use numbers that are between 1 and 10. Now, I know that could sound like aliens talking to understand that. So I'm going to show you how to write numbers in scientific notation. Okay. What I want you to do is, whole numbers always have decimals at the end. Right? We just don't write them again because mathematicians are lazy. So we're going to count how many times we move the decimal point so that we get to in between 1 and 5. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You always want to move the decimal point in between the first two numbers. I want you to look at this number here. To write this in scientific notation, it would be 1.596 times 10, because it's base powers of 10, to the 10th power, because we moved our decimal point 10 times. So if we were to take this decimal and multiply it by 10 to the 10th power, it would equal this large number here. So this is how to write the number in standard form. 1.596 times 10 to the 10th power. This is a lot easier to write than this number here. Let's take a look at another example. Okay. 902 million. We're going to move the decimal point until we get between the 9 and the 0. So 1, 2, 3, 4, 5, 6, 7, 8. So this becomes 9.02 times 10 to the 8th power, because we moved our decimal point 8 times. Or if some of you lose track in moving your decimal, you can look at how many numbers come after this. 1, 2, 3, 4, 5, 6, 7, 8. And welcome to the Fallstick Flipped Classroom Freeze. This video is to see if you're really watching watching the entire flipped classroom videos that you're supposed to watch for homework. So this is Lincoln here. Lincoln just ate 3/5 of his food. What percentage of his food did he eat? For extra credit, what I want you to do is answer that question on the back of your graphic organizer. Don't tell the other kids though, because I want to see if they're watching the video too. So Lincoln, what is 3/5 of your food? I know you know, but I want to see if the rest of the kids know. So again, answer the question on the back of your graphic organizer. Okay, back to the video. Okay, let's look at one more example. 61,400. This number is still slightly small compared to the other numbers, but scientists and mathematicians still use scientific notation to write the numbers. So let's take our decimal point. 1, 2, 3, 4. I'm going to box, or octagon, where I have the numbers. So this would become 6.14 times 10 to the 4th power. Okay? So now what I want you to do is take out your graphic organizer. We are focusing on writing scientific notation with large numbers. So you're going to move the decimal point to the left and count the spaces. So I know my decimal point has to go after this first digit. And I'm going to count either the numbers or I can count how many spaces I moved my decimal point. For me, it's easier to count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5.679. I stop when I get to a 0. Times base 10 to the 9th power. Okay? So again, just to kind of summarize a little bit, and I'll zoom in a little bit more. This becomes scientific notation when you have a very, very large number. We multiply by base 10, and we have to have a number here that is between 1 and 10. 5.679, you can look at the whole number as 5, so it's between 1 and 10. So you count the number of decimal places, which is 9, so it's multiplied 10 to the 9th power, 5.679, which is the digits that we have here. Okay? So we will take this a little bit further in class tomorrow and start applying this concept to real world. Have a good night, everyone. I'm still in space. Hopefully I'll make it to class tomorrow.